2014 question number 5 starts off by giving us this big chart of values of two different functions and their differentials, or first derivatives, telling us that it's twice differentiable and for all real numbers, etc. And question A starts by asking us to find the relative minimum of f on this closed interval. Now normally, if we see a closed interval and we see the word minimum or maximum, we do a t-chart and we find their absolutes. But keep in mind the key word though is relative minimum. They're not asking for an absolute, they're asking for a relative minimum. So instead of making a whole t-chart of f of x and f prime, I'm simply going to use my definition for a minimum. A minimum is when f prime of x is equal to 0 and f prime changes from negative to positive, which makes sense because if you have a normal function here, the parent function, the slope here is going to be negative, the slope here is going to be positive, 0 in between, and that's what makes a minimum. So at x equals 1, f prime is 0, and f prime changes from negative to positive. And that only happens once, so my only minimum value, or minimum point, x-coordinate I should say, is at x equals 1. This question is only worth 1 point, and that's straight for the answer. Part B is asking us for why there can be a value of c between -1 and 1, such that that second derivative is equal to 0. Now anytime I see or read this kind of legal math jargon, I always know it's going to be some sort of theorem. So the first thing I'm going to do is, I notice I have an interval and I have a rate, so I'm going to find the average rate of change for f double prime, that is, using my algebra 2 slope. So the one that we all know and love, y2 minus y1 divided by x2 minus x1. Well, if I take the derivative of f prime, the derivative of f prime gives me f double prime. So I'm going to find the average value of f double prime. So f prime of 1 minus f prime of -1, because remember, that's the interval we're evaluating from, minus, or divide by 1 minus -1. Ultimately, I get 0 over 2, or just 0, and that tells me that my average rate of change for f double prime between -1 and 1 is 0, and that matches up exactly. The reason why is by mean value theorem. That's a big theorem behind this. It tells me that if I have an average rate of change here, at some point my actual derivative is going to equal my average here. You know, at some point. That's ultimately why I did my algebra 2 slope, but nonetheless, you get this question is worth 2 points, 1 point for your algebra 1 setup, and 1 point for knowing that it was mean value theorem. Now C is actually easier, at least in my opinion. They want you to find h prime of 3 and tell you that the parent function, h of x, is the natural log of f of x. You have to know how to take the derivative of the natural log, which is simply, if the natural log is ln u, the derivative would be 1 over u, that u, times the derivative of u. So here's what I mean. My u in this case is f of x, so I put 1 over u times the derivative of whatever my u was, or in this case it's f prime. So that's why I have this fraction f prime divided by f. Now this setup by itself is worth 2 points. The actual answer is only worth a point, but I mean it's still pretty easy to get. All you do is plug in 3 for both the top and bottom, and you get 1/14. But again, the setup in this case is going to give you the most points. Part D, they want you to evaluate this integral, and in all honesty, I think my method is probably easier. The answer rubric will try to give you a more complicated answer, so I'll go ahead and show you my method first. I noticed that I have an f prime, composite function, and then the derivative of g outside, so automatically I see a u sub opportunity. And it's a fairly easy one. In this case, I let u equal g of x and du equal g prime dx. So when I rewrite this, instead of having f prime of g of x, I'm going to put u there, so f prime of u times g prime, or just du. Now I have this simple integral. But remember though, to convert your bounds from u1 to u2, and you'll see how I'll get those later. But when I integrate f prime by itself, I just get f, the parent function. And for my new bounds, if I let u equal g of x, then when I plug 3 in, 3 into g of x, using this chart, I get 3 g of x, 1. So that's my upper bound for u bounds. And then my lower bound was -2, so -2 here, g is right there, so my lower bound is going to be -1. So when I evaluate this, it's simply f of 1 using u bounds, remember that, minus f of -1, 2 minus 8, and I get -6. That method I think is fairly easy and nothing too complicated at all. But the answers, they may want you to use the fundamental theorem of calculus, just knowing that if I take the integral of a derivative, because again remember, the integrand, or whatever is inside the integral, is a derivative of my original. So if I take the derivative of f, I would get f prime of keep the inside the same times the derivative of the inside. And all they want you to realize is if I have a derivative inside, I can take the original function from b minus lower bound a using the original function. But again, we get to the same thing. A and b here, we evaluate here and here. They're both the exact same thing. You get -6 in both cases. But for the case of this AP exam, they want you to know that it was fundamental theorem of calculus, part 1 or part 2, one of those ones. But you do get a point for the actual answer. So if you were to use this method, at least you get 1 point for the correct answer.